Before history, before memory, before the first breath was ever drawn, there was only the silence of the unfinished. Imagine a time when the concept of life did not exist. The universe was vast, cold, and indifferent. Stars lived and died in the crushing dark, forging elements in their nuclear hearts, scattering dust across the cosmos. But in one obscure corner of a spiral galaxy, gravity began to pull that dust together. It was not a gentle process. It was violent. It was catastrophic. It was the birth of our home. But the Earth you know, the blue marble, the white clouds, the green forests, is nowhere to be found. Travel back 4.5 billion years. We're descending into the Hadean Eon, named after Hades, the underworld, and rightly so. Look at the surface. There is no solid ground, only a churning ocean of magma. The heat is unimaginable. The planet is spinning wildly, much faster than it does today. Days are short. The sky is a bruising shade of orange and black, choked with thick clouds of volcanic ash. There is no oxygen to breathe. If you were to stand here, your lungs would fill with nitrogen, carbon dioxide, methane, and ammonia. It is a toxic cauldron, a world that seems determined to prevent anything from living. And yet, look closer. Beneath the violence, the stage is being set. The earth is cooling. A crust begins to form, black, jagged rock floating on the mantle. And then the great deluge begins. As the temperature drops, the steam in the atmosphere condenses. Rain falls, not the gentle rain of a spring day, but a boiling, acidic torrent that lasts for millions of years. It fills the lowlands. It drowns the craters. The first global ocean is born. It is dark. It is hot. It is rich in dissolved minerals. It is a primordial soup. And in this soup, the laws of physics are about to give birth to the laws of chemistry. The ingredients are here, simple molecules: carbon, hydrogen, nitrogen, oxygen. Let us pause to consider the architect of life, carbon. Why carbon? Because it is the friendliest atom in the universe. It loves to bond. It can hold hands with 4 other atoms at once, creating long chains, rings, and complex scaffolds. Without this unique flexibility, the story of life would end before it began. These atoms drift aimlessly in the water and the air. On their own, they are lifeless gas and dust. They need a catalyst. They need power. The early Earth is a planet of boundless energy. Look up. The sun is younger, fainter, but it bombards the planet with harsh ultraviolet radiation, unfiltered by any ozone layer. Volcanoes erupt underwater, spewing heat and chemicals from the planet's core. And then there is the lightning. Storms rage across the planet with an intensity we cannot fathom. Bolts of electricity tear through the methane-rich sky. The heat of the lightning channel reaches 30,000 degrees Kelvin, hotter than the surface of the sun. In that split second of terrifying heat, something fundamental changes. The shock wave shatters the strong bonds of the gas molecules. Atoms are ripped apart. They are chaotic, free, and desperate to recombine. Carbon grabs onto nitrogen. Hydrogen latches onto oxygen. They forge new alliances, stronger alliances. Formaldehyde, hydrogen cyanide. These are poisonous to us now, but back then they were the intermediate steps, the stepping stones. As these new molecules rain down into the ocean, they react again, and slowly, from the chaos of the storm, a specific structure emerges. A central carbon atom, an amino group, a carboxyl group, and a side chain that defines its character, the amino acid. But the storm-lashed surface is not the only candidate for life's cradle. We must look deeper. Dive beneath the waves, down into the crushing pressure of the abyss where the sunlight never reaches. Here, we find the hydrothermal vents, not the violent black smokers that spew acid, but the gentler white smokers, the alkaline vents. These are towering cities of carbonate rock rising from the seafloor like Gothic cathedrals. Inside these rocky towers, warm alkaline water from the Earth's crust meets the cool acidic ocean water. This clash creates a natural battery, a flow of energy. The rock itself is porous, filled with billions of tiny microscopic chambers. In these tiny pockets, molecules are trapped and concentrated. Heat and minerals act as catalysts. Here, protected from the ultraviolet radiation above, simple chemicals are coaxed into joining together. It is possible that the first amino acids were not forged in the sky, but cooked in the warmth of the Earth's deep crust. However, the Earth was not working alone. While the storms raged below and the vents churned in the deep, the heavens were delivering their own cargo. We must remember that the Earth is not a closed system. Between 4.1 and 3.8 billion years ago, the solar system was undergoing a violent reorganization, the Late Heavy Bombardment. Giant rocks, icy comets, and asteroids were flung from the outer solar system toward the inner planets. They slammed into the young Earth, pulverizing the crust. Destruction? Yes, but also delivery. We have analyzed meteorites that fall to Earth today, like the Murchison meteorite. And inside these rocks from deep space, we find something startling. Amino acids. Glycine, alanine, glutamic acid. They were formed in the cold vacuum of space on grains of interstellar dust billions of years ago. Think of the implication. The building blocks of life are not unique to Earth. They are everywhere. The universe is saturated with the potential for biology. These cosmic seeds rode the backs of comets, survived the fiery entry through the atmosphere, and seeded the early oceans. So the broth thickened, from the lightning above, the vents below, and the stardust beyond. The oceans became a vast, global laboratory. But we have a problem, a scientific paradox. Amino acids floating in an ocean are just floating. Water is essential for life, yes, but water is also destructive. It tends to break down complex chains, not build them. If you leave a protein in water long enough, it dissolves back into amino acids. So how did life take the next step? How did these single bricks join together to form a wall? We need a mechanism to forge the bond, to stitch them together. We need a shoreline. Picture a volcanic island rising from the sea. At the edge of the water, there are tide pools. The moon, much closer to Earth than it is today, pulls the tides with ferocious power. The water rushes in, bringing the amino acids. The water rushes out, leaving a shallow puddle. The sun beats down. The heat from the volcanic rock rises. The puddle evaporates. This is crucial. As the water disappears, the molecules are forced together, crowded into a tight space. They adhere to the surface of clays and minerals. These minerals act as a template, a scaffold. They align the molecules in the perfect orientation. As the heat bakes the mud, a chemical reaction happens, condensation. The amino acids link up. They hold hands. They form peptides. Then the tide returns. The water dissolves them again. But some of the chains hold. Day after day, million years after million years, the wet-dry cycle, the heartbeat of the chemistry. Pump, bake, link. Pump, bake, link. Nature is knitting. And here lies one of the deepest mysteries of all, the mystery of the left hand. In a chemistry lab, when you create amino acids, you get an equal mixture of left-handed and right-handed shapes. They are mirror images, like your own hands. But when we look at life on Earth, from the bacteria in the soil, to the trees in the forest, to the cells in your body, we find only left-handed amino acids. Why? Why did nature choose a side? Perhaps it was a chance event in the early solar nebula.
Perhaps the first successful chain just happened to be left-handed and it consumed all the resources, starving out the right-handed competition. It is a ghost in the machine, a fingerprint from the dawn of time that every living thing still carries today. What is happening here is profound. Consider the alphabet. With just 26 letters, you can write every book in every library, every poem, every law, every love letter. The letters themselves have no meaning, but arrange them in a specific order and you create Shakespeare, you create Einstein. Amino acids are the alphabet of life. There are hundreds of types, but life on Earth chose just 20 specific ones, the canonical 20. In those warm, drying pools of the Hadean Earth, these 20 letters were being shuffled, random combinations. Most were nonsense, static, useless. But purely by chance, some combinations began to do something new. They folded, they created shapes, they created function. This was no longer just chemistry, this was the prelude to biology. Matter was beginning to store information, matter was beginning to remember. These primitive chains, these pre-proteins, were the ancestors of the machinery inside you right now. The hemoglobin that carries your oxygen, the insulin that regulates your sugar, the keratin in your fingernails, it all started here in the mud and the lightning. It is humbling to look back across the abyss of time, to realize that the difference between a rock and a human is not the atoms themselves. We are made of the same carbon, the same nitrogen, the same stardust as the barren asteroids drifting in the dark. The difference is the arrangement. The difference is the complexity. Look at your hand. Turn it over. Look at the veins beneath your skin. Feel the rhythm of your pulse. That blood flowing through you is a salty echo of the primordial ocean. The proteins building your cells are the direct descendants of those first fragile chains forged in the storm. You are not separate from this planet. You are not a visitor. You are the earth that has learned to walk. You are the universe that has learned to think. We search the skies for signs of alien life. We listen for signals, but perhaps the greatest miracle is the one we overlook because it is too close. The miracle that chaos, given enough time, turns into consciousness. The fire of the Hadean earth has cooled, but the fire of life burns on inside of us.